Episode 22 of the World of FPGA podcast. VHDL Testbenches have many interesting features to simulate and test your VHDL module. Let's have a look into these functions. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. With VHDL, I will not talk about Verilog. There are other specialists, and I'm doing only VHDL. I can read Verilog a little bit, but it's not my favorite language. Testbenches are very important while developing FPGA firmware. You can just test against your expectations. You can also test against standards to see, is my system working as I expected? And yes, you can discard simulations and only test in hardware. But then you may have some overlapping with other problems. And you maybe wouldn't see problems between modules you have in your system. And it will take it will cost a lot of time, because every time you change something, you have to synthesize it, you have to implement it, you have to load it on your FPGA board, and you have to test it, and so on and so on. So it takes just a lot of time. Okay, simulations also take some time, but most time it is often shorter. And in this episode, I will talk about some features of the VHDL testbenches you can use. So VHDL testbenches, as the basic here, as the name says, you can test VHDL modules with the help of VHDL testbenches. So you stay in the same language you are developing your code. That's the first, I think, very important thing. Our testbenches has no connection to other languages. You're just using your language you are programming in. And if you first see a testbench, you will see that there are no ports, since we are staying inside a simulation. Normally, VHDL modules have ports to the outside just to connect to the real world, but a testbench is a closed system, so if you're writing a testbench, you will never have any port going outside, because there is nothing in the outside. In our simulation, we are instantiating our device under test, our DUT, just as a module, as you are instantiating other things in your VHDL code. And as our module needs input, or needs a lot of inputs, for example, clock and data, or strobe lines, or an XE interface, or something like that, then we have to generate it in our testbench. And there are different ways of creating, for example, clock signals or other signals. I will not go deeper here, because it's just a podcast and I cannot show you things. That's more in our courses here on the World of FPGA platform. There I can show you how to generate different kind of clock signals. In a simulation, we can also use time-dependent commands. They're calling, they have a syntax like wait for 1 microsecond. That you cannot synthesize this, you cannot implement it, because we have no time-based systems here. But in a testbench, you can say, okay, wait here in this line for 1 microsecond and then go on. So we can write a kind of state machine going step by step through our system. The same is for incoming data signals. We also have to generate them. Sometimes it's only a data word and a strobe signal. Then we can use the wait command and wait for the output. And if we have simulated it and looking at the output signals, we can also check if it is the same as we have expected. And we can also look inside our VHDL module, which component in our module is doing what things, and what are doing the flip-flops and so on. Another interesting point is we can use data files. So another way of testing is we have on the input side data files and also maybe on the output side. So we can read, for example, standard logic vectors from a file as an input data. And we can write such vectors also as also on the output side. And I use this, for example, if I'm testing signal filters or signal processing systems, and I'm creating or using real input signals or creating maybe a noisy input signal. And afterward, I'm just analyze this output, for example, with Octave or with MATLAB or something like that. So it's possible to write and also to read standard logic vector files with Octave and MATLAB. And that is a quite interesting loop to test and to development. And you also can have multiple modules in your test bench. A test bench is not limited to one module. You can also instantiate different modules inside your test bench, and so you connect them in your test bench. If you have some blocks from different designs, you can combine them, and so you can also test complex designs and have a look into the behavior between the modules and also inside of each module. Another interesting point is it is also possible to get feedback from your simulation on the command line. You can put in comparison after some time. So your module will need some time to doing, for example, a calculation, and you can check the output if it's equals to your expectation, and then your test bench give you a printout like okay or fail. All the things you can do by hand. You can program it into a test bench and testing other things. And today it is also possible to use some automation. But there are also different possibilities like verification models. And you can use, for example, UVVM or OSVVM. There are some standards you can use. They're on, I guess, on GitHub, and there are a lot of tutorials. And both have the possibility to give you input and output modules. For example, for AXI or for other interfaces. There are also wrapper for clock generation or for signal reset signal generation and so on. And other parts in this verification languages or methodology is more. They are checking your expectation of the signal. And well, it is good to get more and more in touch with such systems, and this is also what I have on my to-do list for this year, to go deeper into UVVM and to get deeper into the verification methodology. So that's all for today. Further information can be found at world-of-fpga.com/WFP022. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.